Okay, so in this video we will see how to calculate the torque caused by a force at an angle. Let's imagine that there was a force here at, say, a 40-degree angle, and the force was 10 newtons. What is the torque created by that force relative to this axis of rotation? Okay, so we look at that and we've got our torque equation, and so we're going to say torque is equal to 10 newtons times R, and let's just say that this is 1 meter, this is 2 meters, so we're going to draw our R vector here like that. So that's R, and then you can see the angle between R and F is 40 degrees, so we say 2 meters times the sine of 40 degrees. So then we can enter this into our calculator, and we'll get a value of 12.9. 12.9 Newton meters. Let's look at another example. Change color here so you can tell it apart. And you just want to be careful if, so for example, if we had a force being exerted here, and then this angle was labeled as, let's just say 30 degrees. Let's say this is a 20 or 2, let's make it big. Let's make it a 205 Newton force. There we go. So let's calculate the torque for this. So you might be tempted to just say tau equals 205 newtons times, remember 2 of these lines is 1 meter, so that's 1 meter times the sine of 30 degrees. You might think, oh, I'll just do that. But in fact, you don't want to use 30 degrees. And if that becomes more clear, if we draw from our axis of rotation over, and we see that 30 degrees is not the angle between R and F. The angle between R and F here is more than 90 degrees. It's 90 degrees plus 30, and so that's 120 degrees. So we want to use 120 degrees there. And just a quick calculation. Make sure your calculator is in degrees, and 178 Newton meters. And you might think, well, what if I had drawn this force here? What if I had drawn it like this? Extend that line. What if I had drawn it there instead? And then I would have seen that this angle right here is 60 degrees, pardon me. And so if we redo that calculation, 205 times 1 meter times 60 degrees, we get the exact same answer, 178. And so say, or 60 degrees. So there's multiple ways you can show the intersection between R and F and label the angle. But regardless, you're always going to, if you draw them in the right direction, you're always going to get 60 degrees or well, for this particular example, you're always going to get 60 degrees or 120, and so it's going to come out the same. And so those two angles add up to 180, and so for the sine of either angle, you're going to get the same value.